Welcome to solving equations by using multiplication and division. Let's first take a look at the properties to understand how to do the problems. The multiplication property of equality is quite simple. What it's saying, in order to keep an equation balanced, is, for example, if I have A equals B, if I'm going to multiply A times C, in order to keep it balanced, I have to multiply B times C. For example, if I have 6 equals 6, and I'm going to multiply this side by 2, I have to multiply this side by 2 in order to keep the equation equal to each other. And the same goes with the negative. If I have 9 equals 9, and I'm going to multiply this side by a negative 3, then I have to multiply this side times a negative 3 in order to keep the equation balanced. Notice I'm not keeping the same value, but in the end, my values are equal to each other, and that's what's important. That's what makes a sentence true. And the same goes with the division property of equality. If I have A equals B, and I'm going to divide this side by a number, then I have to divide this side by a number. Let's take, for example, 15 equals 15. That statement is true. 15 does equal 15. But if I'm going to divide this side by 3, which will give me 5, well, 5 doesn't equal 15. In order to make that statement true, I have to divide this side by 3. Now my sentence is true. 5 equals 5. The only number you cannot divide the bottom by is 0. Your C can never equal 0. That's because you can never have 0 in the denominator. It will make your statement untrue. Okay? Let's go ahead and take a look at some examples. Let's say I have t divided by 3 equals 7. The best way I like to take a look at it is I like to say, well, first of all, I have to isolate my t. I have to get t all by itself. And the way I do that is I need to move the 3. Now, or I need to separate the t from the 3. They're connected through division. Remember, a fraction is another sign for division. The opposite of division is multiplication. So I'm going to multiply this side by 3 and multiply this side by 3. Those cancel out or make 1 t equals 27. 27, I'm thinking 8 or 9. Okay, equals 21. Now ask yourself, does 21 divide by 3 equal 7? The value is the same on both sides because 7 equals 7. Therefore, it is true. Let's take a look at another one. 18 equals W divided by 2. Now, I need to separate the 2 from my variable. In order to do that, it's connected through division. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. Hence, canceling that out or making it equal to 1. And let me go over here and show you, because if I have 2 over 1 times 1/2, 2 times 1 is 2, 1 times 2 is 2, giving you 1. And I don't write the 1 in front of a variable. And then 2 times 18 is 36. Go back and plug it in. 18 equals 36 divided by 2. If I solve it, does 18 equal 18? My sentence is still true. Let's go on and do another one. What if I have two fractions? What if I had n divided by 3 equals negative 2/5? Okay, now this gets confusing to a lot of kids. I have my variable here. It's connected to the 3 through division. The opposite of division is multiplication. So I'm going to divide both sides by 3. That cancels out, leaving me just n equals, and now I solve. My numerators straight across. Negative 2 times 3 is negative 6, and 5 times 1 is 5. There you go. Let's try another one. I like these. These are fun. These are probably my favorite. Okay. What if I had 2 1/4 times g equals 1/2? Fractions always freak people out. Please don't get freaked out by fractions. I like to do my Earth cycle. 4 times 2 plus 1. I keep my denominator the same. And I do my cycle. 4 times 2 is 8, plus 1 is 9. It goes right on the top. G equals 1/2. Now, it's connected through, I have 9/4 G. It's connected through multiplication. In order to solve this, you have to find the reciprocal of 9/4. You need to go back and take a look at our identity and equality properties back in chapter 1. The reciprocal of 9/4 is 4/9. The whole purpose is to make, you can cancel those out, which give you 1g. But what I do to one side, I have to do to the other side. Okay? Now I'm going to go ahead and I can do it one of two ways. I can say 4 times 1 is 4, and 2 times 9 is 18, and then reduce by 2, which 4 divided by 2 is 2, and 18 divided by 2 is 9, so I get 2/9. Or I can say 1/2 times 4/9. I can cancel. I can see 2 and 4 I know have a common factor, and I'm going to divide by that common factor, which gives me 1 over 2 divided by 2 is 1. 4 divided by 2 is 2. I didn't do anything with the 9. And 1 times 2/9 is 2/9. I get the same answer. So you can do it one of two ways. Let's do another one. 42 equals negative 6m. In this case, notice my m is connected to the negative 6 through multiplication. The opposite of multiplication is division. That gives you 1. See, it even makes a 1 when you cancel it out, leaving me with m equals, and negative 6 divided by, 42 divided by negative 6 is negative 7. Another way to do it, which I don't like this way, I like that way, but another way I have to teach you, I just have to teach you. If I have 42 equals negative 6m, the reciprocal of negative 6 is 1 over negative 6. So I can also multiply by 1 over negative 6 both sides. That cancels out, leaving you m, and gives you 42 over negative 6, which is negative 7. Okay? I prefer to do it this way, but you can do it either way. It's the exact same thing. Let's do some more problems. (13s) equals 195. I'm going to divide. 13's connected to the s through multiplication, so I'm going to do the opposite, which is divide by 13. This creates a 1s, and 13 goes into 95 15 times. And if I were to check it, 13 times 15 is the same value of 195, because 195 equals 195. Let's do another one. Negative 3x equals 12. The negative 3x is connected to the x through multiplication. The opposite of multiplication is division. So I'm going to divide both sides, because what you do to one side, you do to the other side. When you cancel it out, it equals a 1x. And 12 divided by negative 3 is negative 4. When I plug it in, negative 3 times negative 4 gives me a positive 12. And 12 equals 12, hence making that sentence true. Let's take a look at another one. 84 equals 3b. The 3 is connected to the b through multiplication, so I'm going to divide each side by 3. That gives me 1b. And 84 divided by 3 is 28. If I said 84 equals 3 times 28, and 84 equals 84, then I know my sentence is true. Let's take a look at another one. Negative 42 equals negative 3s. The negative 3 is connected to the s through multiplication, so I'm going to do the opposite, which is divide. I'm going to divide by negative 3. That gives me a 1. S equals positive 14. And if I substitute it back in, I get negative 3 times 14, and I get negative 42 equals negative 42, which makes that sentence true. Let's go ahead and do some multiplying and dividing with when we have to write the problem out. Okay? We have a negative 18. So negative 18 times a number, any variable that you want, equal negative 198. So we have, I'm going to rewrite my problem over here. Remember, when multiplying, I just have to push them to the coefficient and the variable, just have to push them together, equals negative 198. Now I'm ready to solve. The negative 18 is connected to the x through multiplication. The opposite of multiplication is division. And what I do to one side, I do the other side, making this a 1. Negative 18 over negative 18 is 1, leaving me with 1x. And negative 198 divided by negative 18 is 11. Next one. Negative 42. Negative 42 equals the product of 6 and a number. The product means multiply. What am I multiplying? I'm multiplying 6 and a number. So I'm multiplying 6x. In order to solve, I need to isolate my variable. I need to divide both sides by 6 because the 6 is connected to the x through multiplication. The opposite of multiplication is division. That equals 1. Bring down my equal sign. X equals negative 7. Let's take a look at another problem. 5 times a number means equals 120. I'm going to push the 5 and the x together, equals 120. The 5 is connected to the x through multiplication, so the opposite of multiplication is division. I'm going to divide 5 on both sides to keep the value of the problem the same. And x equals 120 divided by 5. 5 goes into 12 twice, which 5 goes into 12 twice with 2 left over. And 5 goes into 20, not 5 times. I'm sorry, 4 times. And therefore x equals 24, or 5 times 24 is x. Okay, on to the next problem. Fractions. Everybody loves fractions. 1/3, don't be scared. It's just a division problem. That just means 1 divided by 3 equals negative 7 times a number. All you have to do is break this down. I'm going to come over here and rewrite it all together. 1/3 equals negative 7x. The negative 7 is connected to the x through multiplication. The opposite of multiplication is division. So I'm going to divide by negative 7. Now I have 1/3 divided by negative 7, or 1/3 divided by negative 7. I'm going to put a 1 under that so they're both fractions. Remember, in division, I have to change the division sign to multiplication and flip the fraction. So 1 times 1 is 1, and 3 times negative 7 is negative 121. negative 21. Okay, let's try another one. 2 1/2, 2 1/2 times a number, use any variable that you want, equals 1 1/5. 1 1/5. Come over here. I have 2 1/2 times, or 2 1/2 x equals 1 1/5. I'm going to change this to an improper fraction. My denominator stays the same. And 2 times 2 is 4, plus 1 is 5. X equals 5 times 1 is 5, plus 1 is 6, keeping the denominator the same. Now remember, when I have a fraction times a variable, the way to get around that is to multiply both sides by its reciprocal. The reciprocal of 5/2, I flip it upside down, is 2/5, and what I do to one side, I do to both sides. 5 and 5 cancel out, 2 and 2 cancel out, essentially giving me 1x. And 6 times 2 is 12, and 5 times 5 is 25. That is my answer. It's in simplest form because 12 and 5 do not have any common factors. Let's go ahead and try a word problem. A lot of people, just like fractions, are scared of word problems. The key to word problems is picking out the keywords, just like with writing and algebraic expression. Let's first read through the problem. The discharge of a river equals the product of its width, its average depth, and its speed. At one location on the Mississippi River is 533 meters wide, its speed is 0.6 meters per second, and its discharge is 3,198 cubic meters per second. How deep is the Mississippi River at this location? I'm going to go ahead and I'm going to highlight my question. It's asking, how deep is the Mississippi River? And how deep is a keyword. Now I'm going to go through and find out. First, I have to write the expression or write the equation in order to solve it. I'm looking for its depth. Okay, so I'm going to use, let me get my pen back here. I'm going to use D because I'm looking for the depth. Now, what do I got some keywords in here. Let's point them out. The product means multiplication. And now I need what comes after. And anytime you see the product, it's going to tell you what I'm going to multiply. I'm going to multiply its width, depth, and speed. So let's use the variables width, depth, and speed. Okay, and now let's go through and find the information we need to find, because I have the discharge equals, don't forget we got equals here, the product of its width times the depth times the speed. Now we just need to figure out what the width is, what the depth is, the speed, or even the discharge. Okay, I'm going to go ahead and highlight that. At one location, it is 533 meters wide, 533 133 meters wide, and its speed is 6/10 of a second. Okay, remember we're looking for how deep it is, so we don't know how deep it is. And its discharge is 3,198. Now I'm going to put this information here into my formula. My discharge is 3,198 equals my width is 533. I don't know the depth. That's what I'm trying to find out. And the speed is 0.6. So I need to multiply these two together first. 533 times 0.6. 6 times 3 is 18, carry the 1. 6 times 3 is 18, plus 1 is 19, carry the 1. 6 times 5 is 30, plus 1 is 31. I have one place after the decimal, so I'm going to move the decimal here once. So I get 3,198 equals 319 and 8/10 times d. Now, I need to isolate my variable all by itself. It's connected to 319 and 8/10 through multiplication. The opposite of multiplication is division. And when you do it on a calculator, it equals 10. Okay, so my answer is 10 meters. All the measurements in meters. And I just calculated that on a calculator really fast. Okay, thank you, and on to the next section.